there, ROS developers, and welcome to a new open class. It's been some weeks without doing these open classes, but we are back now, and we are going to have several weeks in a row. We are going to be doing open classes again. So yeah, stay tuned to be aware of the next ones. But today we are on open class number 167, and we are going to be talking a little bit about ROS2, and more specifically about QoS, quality of service in ROS2, and we are going to see some examples of how to manage this QoS using C++. Yeah, we have already done a previous class talking about QoS in Python in this case. Now we are going to see it in C++. All right, the general concept is the same, the concept behind QoS, but there are some things that you need to know if you are working with C++. Yeah, so that's what we are going to be doing today. As always, welcome everybody. Let me know if everything is fine, image is good, sound is good. I'm going to switch right now. I don't want to lose any time. So let me switch right now to my computer screen here. There we go. Let me go there to the open class so that I can see the chat as well here. Hello, Thomas Schoon. He says 167. Wow, yes. So we are getting close to 200 open classes. Hello also to Amna Mazen, Eric Vallow. Yeah, so I think everything is fine so far. So let's get started. Then I don't know if you are new to these open classes. Some of the names I am reading here are familiar to me, so probably not. But here we have Tanmit, who says, this is my first class. What should I be expecting from this? Very good question, Tanmit. So these open classes are classes which last something between 45 to 1 hour, yeah, and basically we're going to explain some topic related to ROS2 in this case, which is going to be quality of service, as you can see here in the class title, managing QoS, which stands for quality of service in ROS2 with C++. So during this class, during this hour, we are going to be explaining a little bit what are these quality of service, what is this quality of service thing, and what it is used for. And we are going to see some practical examples, okay? These classes always are based on practice. So it's not just me talking and explaining something, but I am going to actually be doing some demonstrations with robot simulations, and you are going to be able, and you should also replicate these demos yourself. Yeah? Yeah, quality is the answer, Eric. Yeah, yeah, that's right. Then, okay, so you might be asking now, okay, so how can I replicate the demos that you are going to be doing? The exercises that you are going to be doing? Very easy. So what you have to do is to click on this button that you have right above the chat here. It says fork and open the class rosject. Okay? Everybody who is here should click on this button right now. I'm going to click myself here. Yeah. And what does this button do? Well, it does a couple of things. First of all, as you can see, it redirects you to the rosject page, which is this one. Yeah, it's going to take some seconds to fully load everything. Okay, as you can see, mine is loading. It should take 1 minute at most to load everything. Okay, it has rearranged a little bit everything. You have here in the right side the streaming area. Okay, where you can see here the live stream. You have the chat in case that you want to comment something, whatever, okay? Then let me close all this. Then in your case, you are going to see also that a notebook like this one is going to automatically open, right? Then basically in this notebook, you are going to find the instructions of what I'm going to be doing during this class, okay? So I'm going to be, first of all, I will start by launching a simulation. And then down here, you have some explanations, some demonstrations. We are going to be creating some code. And everything that I'm going to be doing, you have it explained here in the notebook, okay? This is like the reference material, let's say. Eric says, it complained about Safari not being supported, but I'm going to briefly go forward anyway. Okay. Yeah, so officially the supported browser is Chrome. I would say that Firefox also works okay as far as I know. I haven't tried with Safari, but yeah, maybe you are going to find some issues, but I don't think it would be anything critical. So yeah, I support your bravery, Eric. And if you have any issue, just let us know here in the chat. Okay. All right, then, yeah, so have you been able so far to open the rosject? Yes, no? Are you in the same page as I am, here with the rosject open, the notebook opened? Yes, no? Any issues so far? Yes, says Amna, Atul, Tanmeet. Okay, perfect. Then let's just start by launching a simulation, okay? The first thing we are going to do is to launch a simulation. Then, in order to launch the simulation, you have the instructions here. We need to run these two commands, okay? Now, where do we run these commands? Well, in a terminal, right? Then, in order to open a terminal, what you have to do is to come down here to the first icon, here in the bottom bar, yeah, and click here in Web Shell. Yeah, so I'm going to click here, and this is going to open. Oops. Okay. Windows, it's telling me to do some updates, but not now. Thanks. Okay, then we open a shell, a new shell. This is a regular Linux terminal. Okay, nothing special here. And then in this terminal, we are going to run these two commands. Yeah. First, we run this cd command to go to a specific path here, yeah? And then inside this path, we are going to run this script, start basic neobotics sim.sh. Yeah, start basic neobotics sim.sh. So let's copy and paste. As you can see, what I am doing is to copy the commands directly here from the notebook, yeah? Just to go faster, I'm copying the commands directly here from the notebook and pasting them here. Let me show it. I'm pasting them here to the terminal, okay? Then let's execute this command, and we are going to see some lines being displayed here. And after some seconds, we should get a gazebo simulation like this one appearing here, okay? Okay, so right now I can see that the gazebo window has opened here. No simulation yet, so let's wait a little bit. Eric is getting some errors. Yeah, don't worry. As you can see, I am also getting these errors. These are normal, so you don't have to worry. But in my case, I think I got another error, which it is actually important, which is this one, this GZ server crash here. Actually, this is important. So what I'm going to do, okay, you can do it as well with me. Don't worry about these red messages, okay? But in case that you don't get the simulation appearing, don't worry, don't panic. We are going to come here to the shell and press Ctrl-C, okay, to stop it. Ctrl-C, okay? Yeah? Once we have stopped here with Ctrl-C, we are going to run again the script, okay? Just run it again. And now, this second time, I'm pretty sure that it's going to work. There we go. So now it worked. Yeah, now we have the simulation here, okay? These errors, don't worry. These are things related to GC client. to the visualization client, but they are not important. That works fine in the second try. Yeah, sometimes in the first try that we are launching Gazebo, the GC server and everything, it takes some time to start, and sometimes there are some timeouts because of that. Okay, then by just stopping it and relaunching it should work okay. Gazebo looking good here, yeah. So if you can see the simulation here, it means that everything worked okay, yeah? So here you have this world with the robot in the center. This is a Robotics MP400 robot. Okay, you can move around the world like this, zoom in, zoom out, okay? Opened just fine in the second time. Okay, great. Then, now that we have the simulation running, we are ready to start. Yeah? So, we are going to be talking about quality of service in ROS2. So, how many of you know about quality of service or are familiar with quality of service? How many of you are familiar with ROS2? Maybe you know ROS2, but you don't know what quality of service is. Atul is asking, this is the first time I'm joining live class. So are you using Ignition Gazebo or the classic one? Here we are using the classic one. Atul. So this is the classic one. This is Gazebo 11, if I'm not wrong. I don't know. But yeah, this is the classic one, not Ignition. Only the best effort strategy, says here our friend. I don't know how to read that name, sorry. Okay. So yeah, this quality of service concept is something which has been introduced new in ROS2. Yeah, in ROS1, we didn't have to worry about these quality of service settings. So this is something we can say that it's something completely new to ROS2. Yeah, and it comes defined by the fact that in ROS2 the transport protocol has changed. Yeah. In ROS2 we are using this DDS, the data distribution service. Okay, there are some other classes. You can look for them, and we have also some video talking about this DDS. So you can go and have a look at them. Yeah, but basically the underlying idea here is that in ROS2 the transport protocol, yeah, how messages are being transported has changed from ROS1. Yeah, and then because of this, we have these quality of service settings available for ROS2, and this quality of service settings basically allows you to customize how the messages are transported. Yeah, it gives you precise control is the correct word. Yeah, because in ROS2 we are using DDS, and we can change the DDS implementation. This gives us a lot of control over the quality of service settings. Yeah, and this is usually going to be used in publishers and subscribers. Yeah, so as you know, in ROS2 one of the main elements are publishers and subscribers. Yeah, which work over topics. Okay, so we have topics, which are the channels that transport the information. Yeah, and then we can have publisher nodes, which are the nodes that publish information into this topic, and we have the subscriber nodes, which are the nodes that subscribe, that get information from these topics. Okay, then by using the quality of service, we can customize, we can have a lot of control over how these messages are transported. Okay, this is a very complex subject, which it's impossible basically to describe it and to treat it in one open class. But the idea is this one, okay? I just want you to get this general idea that this quality of service allows you to customize and allows you to have a lot of control over this communication, okay? Are the Venkata, are the DDS concepts of data writers and data readers wrapped under ROS2 publishers and subscribers? Yes, exactly. That's correct, Venkata. Yeah. And yeah, so there are many settings that we can tune in the quality of service. We are going to just have a look at one in this case. We are going to have an overview at different ones, but we are going to be practicing with one, okay? Then I don't like to talk a lot. I prefer to be doing things. So let's just start with a first demonstration, okay? So that you can have a better idea of how this works. Then we are going to start by creating a package, okay? Creating a ROS2 package, yeah? So keep in mind that we are working in ROS2, yeah? Specifically, if you want to know it, we are working in ROS2 Galactic here in this rosject, okay? Then what we are going to do right now is to open another shell, yeah? We are going to leave this one here running, okay? Because this is the one that it's executing the simulation, okay? So we don't want to close it. Then what we are going to do is to click here in the plus button in order to open a new shell, a new blank shell, okay? And then in this shell, I'm going to run the commands that I have here in example 7.1, yeah? So first of all, I'm going to, not this one. Let me copy this and paste it. There we go, yeah? So how many, let me know, how many of you are familiar with ROS2? Because here we are doing some things that I'm not going to explain, like creating a ROS2 package. So all these are basic ROS2 things. I don't know if you are familiar with them. If not, here we have Ricardo who says, I know a little, yeah. Me too, I know a little, I know basics. Okay, so I'm going to be, I know working on ROS2 a bit, yes, I know ROS2 basic, okay. Then, all right, so just if you are wondering, what we are doing here is to create a ROS2 package, okay? So you can look more information if you don't know what a package is. Okay, you can go and look for more basic open classes, videos, whatever. Okay, here I'm not going to cover all these details. Okay, because I want to put the focus into quality of service. Okay, but yeah, in case that you don't know all this, you can also go to our courses. In this case, yeah. You can come here to our courses, and for instance, all these basic things are covered in the ROS2 Basics courses, okay, which you have here, ROS2 Basics in 5 days. And you have the Python version and the C++ version, both of them, okay? So in case that you need to get all these basic concepts, I recommend you to have a look at these courses, okay? Because what we are doing today is something a little bit more advanced, okay? All right, then let's keep going. So I'm going to execute this second command here in order to create a package. Yeah, ROS2 package create. This is the name of the package, QoS tests package, okay? And where is this package created? Well, it's created here in the path where I execute the command. Right? Here you can see it, QoS tests package. Now, here in the rosject, we can use a graphical interface in order to work better with all the packages, files, folders that we have, okay? Then in order to open this graphical interface, this code editor, you have to click in this second icon here, yeah? Which says code editor. I'm going to click here myself, and this is going to open the graphical interface right here. Here we have it, yeah? In this case, we are working inside the ROS2 workspace, right? Right here. So if you go inside the ROS2 workspace and inside the SRC folder, you are going to find here the new package that you have just created, okay? You have two other packages, which are the ones, these ones I installed them here already, because these are the ones that allow me to launch the simulation, okay? But the one that we have just created, the one that we are going to be working with today, is this one, okay? QoS test package. And as you can see here, you can open the files, and you have graphical access to all this, which is always much more easier to deal with. Sorry. Eric says, bravely using VI from command line. Yeah, I mean, you are definitely a soldier, a warrior, yeah. So you can edit the files using VI, as Eric does. But yeah, if you want to go for the easy mode and not the hardcore mode, I suggest you to use the code editor. Yeah. All right, then let's keep going. So now we are going to create two files. Yeah. Inside inside our package, okay, the QoS test package, we are going to create two files. One named publisher DDS custom QoS, and the other one named subscriber DDS custom minimal QoS. Okay? Then you have different options. Again, you can create them if you want directly from the IDE inside the SRC folder. For instance, if you right-click here in the folder, you have different options. One of them is new file. Yeah, you can create it like this if you want, and then you can copy the name here from the notebook of the file, paste it here, see? And it generates the new file here. Or you can do it using the touch command, for instance, from the command line, like this. Yeah, it's a subscriber, the one that I am missing. From the command line, you can also create the file, okay? So, cd QoS test package, and then touch src subscriber custom minimal QoS CPP, okay? So, the end result is that inside the package that we have just created here, inside the SRC folder, we have two new C++ files, CPP files. One for a publisher and another one for a subscriber. Okay, so of course, so right now, both files are empty, yeah? We have just created the files, but they are empty right now. So, what is the next step? Well, the next step, obviously, is to put some code inside these files, right? Then, let's start by the subscriber, okay? So, I'm going to copy, again, the code here from the notebook directly, copy, and then I'm going to paste it here directly to the file in the code editor, yeah? Right-click and paste. Okay, I think I didn't copy it properly, so let me go back. Select, copy, and paste. Okay. Okay, I don't know, it was not working with the mouse, but with Control-V, with the shortcut, it works. Okay? Then here, I have copy-pasted the code for the subscriber, and now I'm going to do the same for the publisher. The publisher, we have it down here. If you scroll down a little bit, you're going to find the publisher code. Then let me here copy again the code from the notebook and paste it into the publisher. There we go. All right, then, okay, let's finish putting all the code in place, and then we explain a little bit and we go over these files, okay? Then, yeah, so we have created the subscriber file with the code, also the publisher file with the code, and then the last step is to update the contents of the CMakeList.txt file, okay? This CMakeList.txt file, you have it inside the package, and it has been automatically created, okay? So every time that you create a new ROS2 package, which is based on C++, it's going to automatically generate this CMakeList.txt file, yeah? And this CMakeList file contains different methods and rules for building your package, okay? In this case, let's remove the current contents, and we are going to paste the ones that we have here in the notebook, okay? So again, I copy from the notebook and paste here. All right. And now, once we have everything ready, the last step is to compile, okay? So I'm going to already compile here to make sure that I have done everything correctly so far. So let's go to the root of the workspace here. Then run callcom build command to build my package. Yeah, in this case, as you can see, I am specifying which package I want to build, which is this QoS tests package. So callcom build, packages select. Now I am building this package, okay? This might take some seconds, okay? Because we are building the C++ code, okay? So, yeah, I'm going to explain all this in a moment, okay? I just want to, okay, so here we have an error. Publisher custom minimal QoS, CMakeList.txt. Ah, okay. I think I know what is happening. There is an error in the name of the file. Yeah. See, it says cannot find source file. Publisher custom minimal QoS. Yeah. So this is because where I have the code editor. Yeah. So here in the CMake lists, I am pointing to these files: publisher custom minimal QoS and subscriber custom minimal QoS. Yeah, but my names here are not like this, are different, yeah? So this is a typo in the notebook. This is a typo in the names here, yeah? See, here the name is publisher DDS custom, and here the name is publisher custom minimal QoS. Yeah, so these are the correct names for the files, okay? Not these ones that we have, the ones that we have here in point 1. These file names are not correct, okay? The correct ones are these ones. So let me rename the files. The subscriber, the easiest way to rename it is to right-click on the file and rename, okay? Super, super easy. And then here you put the correct name, which is this subscriber custom minimal QoS. CPP, okay? Subscriber custom minimal QoS. Okay. And I'm going to also rename the publisher to this. There we go. Rename. Let's remove everything here and set the new name. There we go. So publisher custom minimal QoS and subscriber custom minimal QoS. Okay. Now let's rebuild this. And now it should work okay. So how are you doing? Have you created already the package? Have you been able to compile the package? Sorry, mine fails to build and reports an error at CMakeList txt3. Okay, let's see. Let's see if I have the same message. I am currently building still 25%. 75% already. Compile okay with a warning about argc not used. Okay. Okay, yeah, so I am getting this warning as well. So this is expected. We are getting this a warning that we are not using this argc parameter. That's okay. Okay, so don't worry. If you get this message, don't worry. This is expected. One package failed. How can I see build errors? If you have build errors, you should see them here. Venkata. In the logs of your Qualcomm build, you should get any error during the building process. You should get it. You should see it here. Failed. Exited with code 1. Same. Okay, first of all, where are you building? Are you building here in this path, home user ROS2 workspace? Or are you building somewhere else? First thing. In order to run this Qualcomm build command, you need to be here, okay? In this specific path. Okay? Then, do you have this package here in SRC? Inside your ROS2 workspace SRC? You have it here, your package? Yes, okay. Do you have inside the SRC folder these two files? Publisher custom minimal QoS CPP and subscriber custom minimal QoS CPP? Yes. Okay. And in the CMake lists, did you copy and paste the contents from the notebook? These ones here. Amna is saying, sometimes when you copy code with copy sign, it gives errors. You need to select all code of publisher and subscriber. Okay, yeah, that could be. Yeah, what I suggest is that instead of using this copy tool from here, okay, you select the code like this, okay? So select manually the code like this and copy it, okay? Don't use this copy button because, yeah, Amna is right. Sometimes this gives strange problems, okay? So if you have used this copy tool here, what I suggest is that you come back again here to the notebook, you manually select the code, copy and paste it to the file. Okay? Like this. So you remove everything and paste it. Oh, now it's building. Okay, so it was that. It looks like it was that. Yeah. Okay. Very, very good point, Amna. Very good point. Yeah. because I totally forgot about that. Okay, so yeah, then it looks like we have it solved. Let's wait until we have some confirmation that everything has built properly. Yeah, so is it building now? Yes, no? Failed after 46 seconds. Okay, but now you should see some error message here. Okay, for Atul it built correctly. Summary, one package finished. Okay, yeah. Like me. No error messages are shown. Okay. Then there must be something wrong in all these steps. Okay. So I suggest you remove your package, okay, and repeat again the steps here. Okay, so you remove your package and you create it again. You create the files, copy and paste the code manually. Okay, so probably during these steps you did something wrong. Okay, so just go over the steps again. Okay, remove what you have and do it again, and probably it's going to get solved. Yeah, make sure that you also select the CMake list content manually. Yeah, so you have to select manually the code for the subscriber, the publisher, and the CMake lists, which is this one here. Eric says, got a run, work calls, learned much already. Will session be recorded? Yes, Eric, it's going to be recorded, okay? So yeah, as soon as we finish the class, it's going to be uploaded to YouTube, everything, as always, okay? So don't worry. You are going to be able to rewatch it later. All right, so now that we have our codes created, let's have a look, okay? Let's have a quick look at the code. And what do we have here? So let's start by the publisher, okay? So this is a quite minimal publisher structure, okay, with some additions, with some extra things, yeah. But basically, what we are doing here is that we have a class, this class publisher QoS, which inherits from the node class. Okay, then the special thing that we have here is these lines. Okay, so what we are doing here is to define a QoS profile. Okay, as you can see, we are creating here this QoS profile publisher. Okay. And then, depending on the value of this variable, reliability, I am going to change one specific setting from the QoS. Okay? In this case, the reliability. Okay, what is the magic number 10? This is the queue size. Okay, by default, this is the queue size of the topic. So, yeah, by default, you can set it to 10, okay? You can change it as well, but this is part of the quality of service settings, and it's the queue size. Build success with proper copy and paste. Thank you for your help, okay? So basically here, Venkata, in the queue size, you can define the size of the queue. So how many messages can the queue of the topic store, okay? In case that they are not being dispatched for whatever reason. Then, all right. Then we define the QoS profile for our publisher, and we specify here the 10 for the queue size. And then, depending on the value of this reliability, we are going to change the reliability value of the publisher, like this. Yeah. So we access our QoS profile publisher, and we change the reliability like this. Okay. In this case, we are changing it to reliable, and in this other case, we are changing it to best effort. Okay. For reliability, we have basically these two types: reliable or best effort. Okay. The reliable setting is going to make sure that all the messages are sent and received properly in the other end. Yeah? So it's going to prioritize that no message is lost. Okay? Best effort, on the other side, the best effort setting is going to prioritize that messages are sent with the least delay possible, yeah? So that the subscriber always gets the latest message, okay? Even though at the cost of losing some message, okay? This is the difference between reliable and best effort. Yeah? More or less, makes sense. But the object is of the QoS type, correct? Yeah. This is the type of this object, and this is a value that we send to initialize it. Okay? So if we check this, class reference, see, is this, well, actually it's the history depth. Oh, because the one that we are using is see? So this QoS, the constructor requires this value here, which is the one that we are providing. Yeah. Then, okay, so we initialize this QoS element, providing the history depth, which in this case it's 10. Okay, and then for the rest, we have to set it like this. Yeah, if we want to change the reliability, we have to change it like this. Okay. Then, if this reliability variable is reliable, then we are going to set the reliability of this publisher to reliable. Otherwise, we are going to set it to best effort. Okay. And who is going to define the value of this variable? Well, it's going to be the user. Yeah. If we come down here, we can see that we are passing this argv to our class, publisher QoS. Yeah, we are receiving it here as well. And then what we are doing here is to check the value of the argument. Yeah. Then we capture the value of this argument and we analyze it. Okay, and this argument we are going to set it when we run from the terminal this node. Okay, you will see it in a moment. Then here we are creating the publisher. This is the name of the topic, and here we are passing the QoS profile. Okay, but we are also passing another thing, which is the publisher options. Okay, here, down here is where we are defining this publisher options object. Okay, and here we are setting a callback. In this case, we are setting this incompatible QoS callback. Okay, and what is this callback going to do? Well, this callback basically it's going to be triggered when an incompatible QoS event is detected. Okay? So, if an incompatibility QoS setting is detected from the publisher and the subscriber, this event is going to be triggered. Yeah? And when this event is triggered, we are going to be calling this callback that we are defining and setting here. Incompatible QoS info callback. Okay? And this callback, it's very simple. We are setting it here. Yeah? So we are going to print a message here saying, hey, a subscriber is asking for an incompatible QoS. Yeah? And then we are going to print some information here related to the event. Yeah? Like, for instance, the last policy kind. Okay, I know this is C++. Maybe you are not familiar with C++, and this might look very complicated. But are you getting at least the general idea of what we are doing here? Yes, yes. Okay. Roxana also says yes, yes, very clear. Okay, great. Then, finally, once we have created our publisher, and we are passing the QoS settings to our publisher and the publisher options, where we are defining which callback we want to execute when this event is triggered, when the incompatible QoS event is triggered, okay? So we pass all this information when we create the publisher, okay? Then after this, we create a timer object with its own callback, the timer callback. And then we define, so here we are defining everything, and here we are implementing. So first of all, we implement the incompatible QoS info callback, where we are going to print some messages and information so that we know that some QoS settings is incompatible, okay? Here we are implementing the timer callback, and basically in this timer callback, what we are doing is to construct a message and publish this message. Yeah. So here we are creating a message structure. Yeah, which it's based on a message ID. As you can see here, a message ID plus a string which contains the current time in seconds and the current time in nanoseconds. Yeah? So as you can see, we are getting the current time here, and then we convert the current time to seconds, and we store it here, and we convert the current time to nanoseconds, and we store it here. And then we create a string which shows first the current time in seconds, comma, and the current time in nanoseconds, okay? And after this, we concatenate this first string with the message ID, okay? The message ID is going to start on 0, so the first message I publish is going to have the ID 0. The second one is going to have the ID 1, and so on, okay? As you can see, inside the timer callback, we are incrementing this message ID every time, yeah? Then once we have the message constructed, we publish it to the topic, okay? Then here we are defining all the class attributes. And in the main, we are just spinning the node, okay? So that it's going to keep publishing until I manually stop this node, okay? So this is basically the structure of the publisher, okay? Then, what about the subscriber? The subscriber is much more simpler, as you can see. The subscriber, here we have the subscriber class with the constructor, and in the constructor, again, we are creating a QoS profile, yeah? And in this case, we are directly setting the reliability to reliable, okay? Here we are not checking any variable like we are doing here, yeah? Here, directly, we are setting it to reliable, okay? Then we create the subscriber here, and of course, we need to pass the QoS profile, the custom QoS profile, okay? If we don't specify this, it's going to set the default values, okay? Because here, as you can see, we are creating our custom QoS profile, okay? We are creating it and we are changing the QoS settings, okay? But in many examples in ROS2, you are not going to see any of these, yeah? So if you don't change anything, it's just going to set the default values, yeah? Here, by the way, here in the notebook, at the end, you have the default policies, yeah? This means if you don't create your custom QoS profile, then it's going to be created with the default settings, okay? Then, let's go back here let's go back to the code. Okay, then we create our subscriber. Here we have the subscriber callback, okay, where we are just printing the message received here. So I'm going to be printing every message received, and then, yeah, that's it. And then I am going to spin this node, okay? So basically, I have one publisher in one side, which is going to be publishing these messages, okay? And I have this subscriber on the other side, which is going to be subscribing to this topic, yeah, to the QoS test topic, right? I am subscribing to this QoS test topic, and I'm going to be receiving and printing these messages, okay? Then let's execute this already. So I have finished my compilation, so let me source the workspace, very important. And then I'm going to do a couple of tests, okay? Let's go down here. So first of all, I'm going to make sure that I am setting the DDS implementation that I want to use. In this case, I am going to set this Cyclone DDS CPP, okay? So I'm going to set this DDS implementation before I run my publisher. And then I'm going to run the publisher here. And as you can see, here I am setting the reliability value to reliable, okay? Sorry. So what's going to happen? Well, if I set the reliability to reliable, then this if condition is going to be true, right? So my publisher is going to set the reliability to reliable, okay? Then let's start running it like this. There we go. Okay, so as you can see, I am starting here to publish all the messages. Yeah, 0, 1, 2, 3, 4, 5, 6, 7, etc. Okay? Now let's open another shell. And in this extra shell, again, I'm going to source my workspace, set the DDS implementation, and I'm going to run my subscriber. So let's see what happens. Here, by running the subscriber, I start receiving all the messages. Yeah, 31, 32, 37, 38, 39, 40, 41. So I am receiving all the messages, so no problem here, right? Everything is working as expected. My publisher is publishing the messages, and my subscriber is able to receive these messages, right? Let's see here. What will happen if I set both publisher and subscriber as reliable? This is the example that we have here. But have a weak network, messages get delayed or lost. Well, in that case, so the reliable policy, it's going to try to make sure that no message is lost, okay? But if you have a very poor network and you have issues, then there are other policies that might come into play, okay? Like, for instance, policies such as the deadline of the messages, the liveliness, least duration, etc., okay? So that would be a more complex scenario, okay? But yeah, in theory, with a reliable setting, you should not lose any message, okay? Then maybe in another class we can do some additional tests with other settings, like the deadline, liveliness, etc. For this one, it's too much. In fact, we are already we have already spent 1 hour. So sorry, but I have to leave. Says Thomas. Also Venkata. Thank you very much for this course. Great content. Thanks a lot. Yeah. So remember that you are going to be able to review the video later on YouTube. Okay. So yeah. Then let's go with the second example. Okay. So let's go here with the second example. So now, instead of running the publisher with a reliable setting, we are going to change this. We are going to change it right here. We have the command. We are going to change it to best effort. Okay? So now I'm going to change the reliability of the publisher to best effort. There we go. So I start publishing here. And now I'm going to run again the subscriber node. And what happens? Oh. So what happens is that I am triggering an incompatible QoS event. So here in the publisher side, you can read the message. A subscriber is asking for an incompatible QoS. See? So in the publisher side, what happens is that this event callback, the incompatible QoS callback, has been triggered, right? And in the subscriber side, also, I am getting a warning message here which says, hey, new publisher discovered on topic QoS, offering incompatible QoS. No messages will be sent to it. Last incompatible policy, reliability QoS policy. So it's saying that this subscriber, it's not compatible with the publisher. And therefore, even though the publisher keeps publishing the messages, my subscriber is not able to get these messages. See? And this is because, you can have a look here at the table. In this case, we are working with the reliability policy, and we can see that best effort is not compatible with reliable. So if the publisher is best effort and the subscriber is reliable, which is the case of our last example, right? We were setting our publisher to best effort and our subscriber is always going to be reliable because we are setting it here in the code, right? So if the publisher is best effort and the subscriber is reliable, this is not compatible, so the communication is not going to happen, okay? For the rest of combinations, and you can see, they are compatible, yeah? So if the publisher is reliable and the subscriber is reliable, this is compatible, no problem. If the publisher is reliable and the subscriber is best effort, this is also compatible, okay? Yeah? So you can see here this table of compatibilities, okay? Then let's see a very quick example again. This is an exercise, but I'm going to solve it right now so that you can see it, which involves the simulation, okay? So what we are going to do is to create a subscriber for the scan topic, of the robot, yeah? As you can see, this robot has a laser scan, yeah? And we are going to create a subscriber for this laser, yeah? So that I can capture the laser data of the robot, yeah? Then let's create this new CPP file here, subscriber scan QoS CPP. I'm going to do it now. I'm going to go a bit fast, okay? So you can see to what I am doing, and maybe later, with more time, you can try to do this exercise on your own as well, okay? So let me start by creating here the new file, subscriber scan QoS CPP. I'm going to copy the code directly here from the solution, which is also in the notebook. So let me copy this here and paste it to my file. And then I need here to update the CMake lists to generate the new node. Yeah. So here I'm going to generate the node for my new C++ file, which is subscriber, where it is, subscriber scan QoS CPP. Yeah, I'm going to generate the executable for this, exe, there we go, and exe, okay? And in this case, I need to add a dependency, which is sensor messages, okay? Because I'm going to be working with laser data, all right? Then I'm going to install the new executable, also here. And finally, I'm going to add a dependency for the sensor messages package, okay? Again, I'm not going to be explaining what I am doing here. So if you want to get more data on this, you can check other open classes or the ROS2 basics course, okay? So I am generating a new executable from this code that I have just created here, okay? Then what am I doing in this code, in this new code? Very easy. I am creating a subscriber for the scan topic, yeah? And I am going to give the possibility here to modify the reliability policy, yeah? So we can set it to reliable or to best effort. Okay, I can change the reliability policy of my subscriber, okay? And also I am creating a event callback. In this case, an incompatible QoS callback, yeah? So if this incompatible QoS event is triggered, then I'm going to execute this callback here, okay? And then finally, in the laser callback, what I am doing is to print one reading from the laser. Yeah, in this case, the first value contained in the ranges array. Okay? Then let's compile this. So let me come back here. Let me come back to the second shell, and here I'm going to recompile, so that I generate my new executable. Go. So here you have a note that in order to check the topic QoS settings, you can use the verbose tag, okay? Let me go back here to compilation. This is still compiling. So for instance, if I run a ROS2 topic echo of ROS2 topic info of the scan topic, I'm going to get some basic information about this topic, okay? See, the type that it uses, as you can see, it's sensor messages laser scan, the publisher count, so how many nodes are publishing into this topic, and how many subscribers are subscribed to this topic, yeah? But if I add the verbose tag here at the end, I'm going to get also information related to the QoS settings. For instance, I can see that the QoS policy, the reliability policy for this topic is best effort. Yeah? So, if this is best effort, okay, this has finished compiling. I'm going to make one question right now, okay? So now with my node, I can launch it and modify, using the parameter, I can modify the reliability policy, right? So if I set the reliability policy of my subscriber to reliable, what do you think is going to happen? Yeah? So we know that the publisher is best effort, right? We can see it from here, because the current reliability policy is best effort. So we know that the publisher is best effort, and the subscriber that I am going to launch, I'm setting it to reliable with the argument, right? So what do you think is going to happen here? Am I going to be able to get laser data, yes or no? No. Okay, let's see. Let's run it and let's see what happens. Exactly. So the incompatible QoS callback is triggered. Yeah? Because there is an incompatibility in the reliability policy, right? And what if I change it to best effort? Is it going to work now? If I change it to best effort? So we are going to have best effort and best effort, right? Then this is compatible. So it should work. And indeed, it works. Now I am able to get the laser data, right? And this example, we can see it even more clear using ROS. Yeah? So if I launch ROS here, yeah? If I launch ROS here, let me configure here ROS in order to have the robot base link. There we go. So we have, let me add a TF here. So there we have the robot. And I'm going to add a laser scan visualization. Yeah? Laser scan. So I'm going to configure the topic here. Set it to scan. And I am getting no reading, right? So why is this? Well, this is actually because of a QoS setting incompatibility. Yeah. Now in ROS, if we want to change the QoS settings, we have to come here inside the topic. And for instance, here in the reliability policy, we would have to change this from reliable to, for instance, best effort. Now, if we change here the reliability policy in ROS to best effort, now suddenly, as you can see, I can see the laser readings, which are these red things. okay? Because now I have compatible QoS, right? If I change it to reliable, I cannot see anything. And this is exactly the same. Yeah, this is happening because, see? Because you are setting incompatible QoS, okay? No executable found. Yeah, this is probably because you have to update, you have to generate the executable here in the CMake list, in the CMake lists, okay? I'm going to paste here so that you have the updated CMake list here. I'm going to copy and paste it to the chat, okay? So that you can have it. I'm not sure if this is going, I don't think this is going to work. Yeah, no, it doesn't work. Yeah, then don't worry. Just see exactly what I have done here with stopping the video and everything, and you're going to figure it out, okay? But basically what you're missing is to generate the executable, okay? Then, yeah, so I'm going to have to leave it here, all right? We are already 15 minutes past the time. So yeah, if you want to keep learning, so as you can see, this subject has many different layers. So we have just seen a very basic example of the reliability policy, but there is much more, okay? Then in case that you want to learn more about this, you can have a look at the intermediate ROS2 course based in C++, okay? I have left here a link at the end of the notebook so that you can have a look. And here you are going to be able to get a much more in-depth look to all this, okay? So, yeah, thanks to all the attendants. I hope that you enjoyed the class. I hope that you learned something and that you can go home with some new knowledge acquired. And yeah, so thanks a lot for being here with me. I will see you again next Tuesday with another open class. It's going to be very interesting because we are going to be talking about ChatGPT, okay? And how you can use ChatGPT to learn ROS. So yeah, stay tuned. I will see you again next Tuesday. And as always, until then, take care and keep pushing your ROS learning. Bye-bye.